Alright guys, so let's do a problem in your stoichiometry checkup. I'm going to do one and then you guys will have 4 to complete. Now, you're going to need to show your work in this. You can either do it in a Google Doc the way that I'm going to do it, or of course you are free to handwrite it and upload a picture. You'll also need a calculator, your periodic table, and then I have a copy here of the stoichiometry map for you. So, we'll go ahead and open this and then we'll get started. And I don't think I have a calculator open, so I'll go ahead and open that. Alright, so this is in just a quiz form. There's 5 questions, so it will be multiple choice, which means you will probably be able to tell whether or not you have done this correctly. But these questions are going to be multi-step questions that you'll have to use your map for. And I'm just going to do the first one as just a example that you can use to help you set up your problems. Okay, so it says in the reaction, N2 plus 3H2 will yield 2NH3, which is ammonia. How many grams of H2 are needed to produce exactly 1 mole of ammonia? So we are trying to figure out how many grams of H2 are needed to produce 1 mole of ammonia. So we always start with what we know and what we want to get to. And in this case, we're starting with moles of ammonia and we're ending up with grams of H2. So I'm going to bring up my map and we're going to look at where we're starting and where we're going. Okay, so in this case, we're starting with moles. So we're either going to be starting here or here, right? Well, we're starting with our moles of our given, right? Because we're going to be given those moles because it said 1 mole of ammonia, okay? And then we want to end up with our grams of, what was the problem? Sorry, I don't remember. Grams of H2. Okay, so we're looking at for grams of H2. So we're starting with moles of ammonia and we're going to grams of H2. So I'm going to have a couple conversions that I have to do here. I have to go from moles of my ammonia, which is NH3. So I have to go from moles of NH3 to my moles of H2. Okay, so I'm going to use my mole ratio to do that. Then I'm going to have to go from my moles of H2 to grams of H2, and I'll have to use my molar mass for that. Okay, so we're going from moles to grams. Now, we don't always have to start on the left-hand side of the map. Like, for example, in this one, we're starting with moles. But again, remember, you could start anywhere on the map. So you could start on the left-hand side, or you could start with moles. And it just depends on the problem. So let's go ahead and get started. So I'm going to put my font a little bit bigger for you guys. So I'm going to insert an equation, and I'm going to start with what I know. So I know I have 1 mole of ammonia, which is NH3. Remember, we always want to keep our units to make it easy. Okay, so we have 1 mole of ammonia, which is NH3, and I have to go from my moles of my given to my moles of my unknown. Okay, so since the problem wants us to go from moles of ammonia to grams of H2, we have to first go from moles of ammonia to our moles of H2. Okay, and again, we're going to use here our mole ratio. So if we look at our equation, for every 1 mole of, or for every 2 moles of ammonia, which is right here, so 2 in front of the NH3, for every 2 moles of ammonia, we have 3 moles of H2, okay? So it's going to be a 2 to 3 ratio of 2 ammonia to 3 H2. So if we're going to type that in and do our mole conversion with our ratio, we want our moles of NH3 on the bottom because that's what we want to eliminate, and we want our moles of H2 on the top because that's what we're converting to. So there's going to be a 3 to 2 ratio, or 2 to 3 ratio, depending on how you're talking about it. In this case, because the H2 is on the top, we're going to leave the 3 with the H2 and the 2 with the NH3. So whatever the coefficients are, it doesn't matter if the compound's in the numerator or the denominator, whatever number is the coefficient stays with that compound. So the 3 is going to stay with the H2 and the 2 will stay with the NH3. Okay, so it's a 3:2 ratio. Oops. So there are 3 moles of H2 for every 2 moles of NH3. Okay, so there is my first conversion where we go from moles of our given to moles of our unknown. Now, if we look back at our map, so we've done this step. So we've converted from moles of our given to our moles of our unknown. Our last step is to go from moles of our unknown to our grams of our unknown. Okay, and again, we're looking for grams of H2. So I'm going to go ahead and set this up. So we're eliminating our moles. So I'm going to put 1 mole of H2 on the bottom. And I want my grams of H2 on the top. Now where do I find my grams of H2? Well, anytime we're using molar mass, if it's not given to you in the problem, we have to calculate it from the periodic table. So let's go to our table, and we have the average atomic mass of hydrogen is 1.008. Okay, so 1.008 is the average atomic mass or the molar mass of 1 atom of hydrogen. However, this is 2 atoms of hydrogen, so we have to do 1.008 times 2, which is just 2.016. Okay, so in our problem here, we're going to have 2.016. Okay, and that's going to be our grams. Now we have our problem set up and we can solve. Again, this is the molar mass, and we had to, because it's H2, that means there's 2 atoms of hydrogen, which means we had to do 2 times the average atomic mass on the table. That's where that number came from. Okay, so to do this, we will multiply across the top. So we'll do 1 times 3 times 2.016 divided by 2 times 1. So it's just going to be divided by 2. So let's go ahead and plug it into our calculator. So we're doing 1 times 3 times 2.016 6.048. So we'll have 6.048 grams of H2 divided by, now these are all eliminated, so the moles of NH3 went away, moles of H2 are gone, which means the bottom will just be a whole number because these units have canceled out. So 2 times 1 is 2. So we're going to do 6.048 divided by 2. So 6.048 divided by 2 is equal to 3.024 grams. Okay, so the answer here is 3.024 grams. If we go back into our assignment, it rounds it. 3.024 is just going to round to 3 grams. So 3 grams of hydrogen gas are needed to produce 1 mole of ammonia. Okay, and let's submit it just to make sure we're right. And that is correct because it is not flagged. So we did that one right. Perfect. So I have multiple attempts set for you guys on this, just so you can do it multiple times and you can get the highest grade possible. You will upload your work at the end for me just to make sure I can see how you're doing and how I follow it, or I can follow it to see where you're making mistakes. But just remember to use your map. Find where you start. You're not necessarily going to start on the left-hand side. Like in this first problem, we started in the middle. But just find where you start, where you end, and if you just take those conversions step by step, remember the boxes are going to be your units and the arrows are going to be your conversion factors. Okay, so boxes are the unit, arrows are the conversion factors. Each arrow is a step. So like for example, with this one, this was a step and this was a step. So we had 2-step conversions, right? This is what we started. We did 2 steps. Then we got our final answer. Okay? If you need more help with this, let me know. And if not, you guys go ahead and attempt those other 4 questions. And we will review a little bit more before you guys test on this. All right. Cool deal. See you guys in the next one.